Good day, welcome back. Another short video today on my series on chess engines, and it's not so much about the different software and building different engines, but more summarizing some of the information on Reddit and the internet, so on, and blogs about what sort of performance you can expect from certain engines, how to deal with things like the number of threads versus the number of cores, and so on, so on. So just to have a sense of, how to get the best out of your engine. Now, I've done some of this before on when I built Stockfish and so on, but what I want to do is just quickly cover a few topics here about, going to the importance of nodes per second, and then just demoing that a bit on Nibbler and Skid, which we've seen before. Sort of going over my hardware setup, just so you can get a sense of what you can expect from a decent desktop machine, although an older one, and some of the issues to deal with. And then I'm going to do a few speed tests and a few charts just to sort of show you the results I've been getting. And then to close out, I'm going to sort of introduce a new website, Phonics Test Suite for Stockfish, where you can do a bit of a comparison for how your machine ranks with other machines. And I think that the main thing I'm getting at is just make sure you're getting the most out of your machine, because there might be some bottlenecks which are kind of affecting you in a negative way. Okay, I think nodes per second, I think everybody's fairly familiar with the idea that that's pretty much a good metric of how much work your engine is doing. My machine gets about 15 to 17 million nodes per second. Decent laptop might get 10, and my old laptop gets about 3 or 4. So obviously it's much better when I'm doing all the work. I mean, I basically want to do batch processing and analyze a bunch of World Cup games or candidates games or whatever, and use the engine to spot interesting moments in the games. And the more performance, the better. Analyzing an individual position, sitting on an engine is fine. Analyzing a whole game, sure, can take a couple of minutes. But if you've got a faster engine, then it obviously helps a lot if you're doing a lot of games overnight. Okay, and then very quickly, I mean, we were talking different types of nodes, right? At the moment, Stockfish nodes, they're using the neural net for the evaluation phase, and that actually slowed down the nodes per second by a factor of 2 or so, or it depends on the position actually, versus older version of Stockfish where they switched over Stockfish 12. And then the board state is obviously an important factor in nodes per second, and also the neural network based engine such as Leela. Yeah, they might do 1,000th of the nodes because they're doing a lot of work each node versus the Stockfish, which is a lot of tree searching and then just a much lighter node evaluation at the end of the process. So you have to sort of bear in mind the different sorts of nodes we're talking about. In fact, what I might do is I might bring up Nibbler. We've had it running before. Got the page here. You can see that. That's good, right? And then if we run, and what's that showing? That's showing 6.5 million nodes per second. Okay, let's have a look what engine we're running here. Engine threads. That's on 8 threads. Let me throw it up to half the threads of the machine, see what I get. I have to click it. I'm getting 10 to 11 million nodes per second. I mean, I'm running OBS. I'm running in a VirtualBox. Can make some changes here. Threads, go back to 1.1 million nodes per second. It's actually similar to the machine I'm going to show you some charts for later, but it seems to be losing a little bit of engine strength there. Let's just halt Nibbler, and then you go to Skid. Skid, the same thing. Tools, analysis engines. You add the engines here and do the settings. So let's go to 12. So we can just see comparison. Save that. Start it. You have to restart it. And bring up the information tab. And a little bit slower, actually. Anyway, get the idea. You can get 9 to 10 million nodes per second. The GUI does use processing time as well, so that sort of will affect the results that you get. And then just to see the comparison with the Leela engine, just let me close both of those engines, and I'm actually going to set up. Okay, there's Skid running in window, and you can see what I got here. I put this Tal Botvinnik game 6 just before he plays 95, because obviously I showed the position effects a little bit. Now there is. Just press Stockfish play. We're getting 1.1 million nodes per second. Let's boost that to information panel. There you go, 10 million nodes per second using. Now I want to show you is let's close all Stockfish and we'll go to Leela. So Leela is different concept, big neural networks, and the neural networks sort of contain information about the best moves as well as the evaluation of the position. And you can see here, I've got an older graphics card in here and I'm getting 10,000 nodes per second. This can be a bit meaningless because it depends on the size of the neural network you're working with. Anyway, you can see the numbers are a fraction, right? But obviously, as I say, the evaluation of the position comes up with policy which is kind of the move suggestion as well. So a different way of doing it, just so you're aware. That's just want to demonstrate that. So we'll close that window and go back to Ubuntu and continue with what I was talking about. That sort of background. So I want to say I've got this desktop I use for most of my work. I've got double desktops. They're all about the same, 5900X. 2 generations old AMD CPU, very good CPU, but it's quite old and obviously been superseded by more recent ones. It's got 12 cores and 24 threads, and this is what I wanted to get. And basically I come to the conclusion, actually, don't go past the number of cores. It doesn't really help. And just as we go and do it, there are a couple of other things we want to talk about as we go along. So let me show what I did there. Okay, on this terminal, you can see I've already run this command here, Speedtest1, runs this benchmark test within Stockfish using one thread, and that doesn't exist. This is within VirtualBox. I've only given it 18 potential threads, so thread counter 1, and we get 1.2 million nodes per second. And then let me just run that, for instance, at 12 and see what happens. I'll pause it and come back. One thing that will happen is that it certainly starts firing up the fan. My CPUs both have all-in-one coolers, which I think helps a lot. Means that the temperature is less of a restricting factor on the performance than it might otherwise be, because there's nothing much more stressful on a CPU than running chess engine calculations so that you can reach the maximum sort of heat of the CPU pretty quickly, unless it is very well cooled. Okay, let me let that run and come back when it's finished. So there you go, 12 million nodes per second. That scales fairly well, up to 12. Let's push that a bit higher, past the actual number of cores which this machine has, which is 12, and let's see what happens to that number. Let's try 16, and you can see that it's gone up a little bit, but probably not as much as you'd expect for 4 extra cores. And let's do it one more time. Let's do one less than the number of cores and see what we get back. And you can see it kind of caps out at that level, right? So basically, once you've gone past the number of cores, you don't seem to get that much incremental improvement after that. So that was just quickly running it here on my VirtualBox. Now, what I did earlier on the bare metal 5900X running Ubuntu, I did some charts in Excel. Let's bring that up. So here we can see the charts, right? So what I did first off is this was the first version where I was still using an old fan CPU cooler, and you can see as the number of threads increased, so about 1.5 million nodes per second. It got to 12, which gives you about 16 million. That's all kind of, it's not too bad. And then basically that's where it stopped increasing. I did this other chart just showing how hot the CPU got, so that was no good. And so I put on the liquid cooler. And so basically I reran it, and you can see the orange line is the slightly improved one, where after 12 threads, you've got 16 million nodes per second, and then that creeps up to about 17 million nodes per second as you add on the extra threads, which don't seem to improve it too much. You're squeezing a little bit of extra performance in, but it's probably costing you a bit as well, splitting the task up. If you've got issues with, maybe missing more cache and sort of just the interaction of managing a lot more threads by Stockfish, so you don't really get much improvement after you go past the number of cores. So that was basically the sort of the conclusion I was looking at. And actually I've got another quick chart here where I quickly did a compiler option variation. This is just preliminary. I'm just sort of looking at all the different sort of ways you can look at this thing. And here is the when you compile using the native options, you get all the AVVX and pipeline instructions in there, which don't exist in older ones. So if you compile for older CPUs, then you give up about 50% of your performance. So that was quite an interesting observation. Okay, cool. So that was basically just seeing what I could get from my computer. And then now what we're going to have a quick look at is a website called the Phonics Test Suite for Stockfish, and we'll see how our numbers stack up with people doing other tests for their hardware. Here we go. I won't go through the full install this time around, but you can see here's the GitHub repository for the Phonics Test Suite. You do your git clone, you compile it, you need some PHP, packages included, they're the ones there, and then it runs, and then they sort of, if you look at it over there, it says, see that line there, Phonics Test Suite benchmarks.bt. So let's give that a shot and see if that works, spelled properly. And then if you've got that test loaded, don't save the results and just run it. So it just runs tests, small PT, some tests, but I'll let that run. Okay, so it comes back with your score effectively, and then ranks it against other CPUs, which they've done it for on the website. So what we want to do is we want to do the one for stockfish. Just bring up the last command, make that stockfish instead. And if it didn't have that test on it, then Veronica will go and download it and do the test for you. And let's have a look. That will save the results, and we'll just let that run. Okay, there you go. Ramped it up, and you can see the score there. Bit of variation, 15 million nodes per second, which is kind of all we're getting. It's using all the cores, and that puts us in this position. So basically, let's now have a look at the here's the benchmark rankings that they've done. Now, there's the 5950 here, which is 16 cores, and they get 22 million. 15 million for that. It's in a virtual box, and actually, I run it on my other machine. I get that 17 million. So that's fair. I'm quite happy with that because it means that I'm not doing anything wrong. I'm kind of getting the results you'd expect. So you can see that you can actually get 17 million from the newer generation 8 cores. Will basically give you the same numbers my older 12 core one is getting, which you kind of expect. Faster DRAM. Not too sure there's cache sizes. My one might have a bigger cache size, which could help in some situations. So that was basically the conclusion we've got. Okay, so that's all I wanted to cover today. So just the whole process of speed testing my engine just to make sure I'm getting the most out of them, which I am. Of course, I'm not as good as any of the other ones up here. Some amazing machines here, right? Later generations. I'm probably going to do a bit more testing actually, because I think this is pretty interesting. Not just the fact that cores versus threads, but how much is your processing power limited by your temperature? I do do a bit of poking around with undervolting and stuff like that, but not in a serious way. There are power limits on the CPUs, and then can you overclock to get another 5 or 10%? I mean, probably hardly worth it, but particularly the fact that you don't get much more out of adding threads is kind of a little bit disappointing. But I guess that's I've read different things in blogs. My result basically, you shouldn't go past the number of cores. Okay, hope you enjoyed that, and thank you very much for watching.